good day in geometry. We're covering CO2 using algebra to find segment length and determine if two segments are congruent. This is probably one of the more common geometry terms that you are going to see, congruent. Anyone want to take a guess as to what congruent means? Alan?
Same size and shape.
That is absolutely perfect. That's exactly what I was going to write. Yes, congruency means same size and shape. Okay, same size and shape. And there is an important difference between congruency, which we can't see it here. The symbol for congruency is an equal sign with a little squiggly over it, okay, versus the equal sign, which is just the equal sign. But there's a difference between congruency and equality, because what congruency says is that two things are the same. You know, these front two tables here are congruent. Same size, same shape, right? But do they have the same value? Are these two tables equal? No. One might wobble more than the other, right? One might have some chips in it or something like that. Maybe to you, this table was where you met your best friend the first day of school. So this table means something to you. It has value, okay? So when we talk about congruency versus equality, equality brings in value, whereas congruency is just this thing is the same as that thing, okay? That'll come up again later on. And the symbol for congruency, these two segments, AB and CD, we would write that segment AB is congruent to segment CD, which I've got written over here, right? They're the same size, same shape. Only when we assign a value to the segments, if we said segment AB is 10 and segment CD is also 10, only then can we say that the measure of AB is equal to the measure of CD. They both have a measure of 10. Notice that when we talk about their value, the segment symbol drops off. And so if it's just the letters, it's saying what is the value of. Okay? One of those math notation things, like math punctuation almost. So you know what we're talking about. Another word that you'll see very frequently is postulate. We talked about this a little bit with the math packet, but you should always be prepared to defend an answer. You know, I think the example that we used was like in a court. If a lawyer said, my client is innocent because he looks innocent, well, you're not going to win a lot of cases, right? You have to be able to defend it. So postulates and what you'll see later on called the theorems, those are kind of the math rules that we can use to describe why something is true. And this one, which we'll use in CO2 here, is called the segment addition postulate. Okay? Or if you're lazy, you can call it the SAP, or if you're really lazy, it's called the SAP. Right? But the segment addition postulate, any guesses as to what that might be? Okay. The segment addition postulate tells us that the parts of a segment will sum to equal the whole segment. Okay? The parts of a segment will sum to equal the whole segment. Those of you that also like to really argue, you know, you'll really like geometry too. It's kind of like mathematical debate class.
It actually sounds pretty cool.
It is, if you really get into it. Yeah. The parts of a segment will sum to equal the whole segment. Everyone got that definition? Can I erase and scroll? Okay. All right. Pen down, clear ink, scroll down. So for example here, find the segment length. I'm looking for the value of GH. And again, notice there's no segment sign up above GH here. It's talking about the value of it. Take a look at that, and who can tell me what GH equals? Lucas.
15.
And how'd you get that?
I got it by since 36 is F through H. And we know that FG is equal to 21. I took 36 and minus 21 to get GH and got 15.
How do you know that FG and GH have to equal 36?
Because I thought connecting F and there's a line to H above the line.
How do we know that FG plus GH has to equal FH?
Because the segment on top tells us that it's 36.
And because of the
FG is 21.
okay, but how do we know that FG plus GH? Why is this, without putting any numbers in there, why can I write that FG, I'm running a room there, I'm going to write it down here. How can I, no, I'm going up here, sorry. FG plus GH equals FH. Why can I write that and you cannot dispute me? Alan? The SAP, right? The segment addition postulate tells us that the two parts of this segment, FG and GH, have to add to equal the whole thing. Now, I'm sorry, because it's very obvious that it's 15, right? Because we're 8th graders, 36 minus 21 is 15. But if someone asks you for the mathematical reason why, the answer is the SAP, okay? The segment addition postulate. Now, we can use this and we can say, okay, I know that FG is 21. GH is what I'm trying to find, but I know that FH is 36. And what we've just done, starting with the segment addition postulate and then plugging in the information that we know, the measure of FG and the measure of FH, we've set up an algebra equation, a simple one, that we can solve, right? Subtract 21 from both sides, and we get GH is a value of 15. But that's the mathematical debate, right? The debate is very logical, very cut and dry. Can't dispute it. Yeah, Alan.
Oh, no, I was going to do the answer for the next one.
So for the next one here, I want you to start by using the segment addition postulate to set up an equation, not using numbers, right? But with the segment parts and wholes. Because of the segment addition postulate, what do we know? Alan?
I was going to say the answer. But should we do I'm just going to say VW plus WX equals VX?
Yes, VW plus WX has to equal VX. Undisputable because of this app. And if someone says, well, I don't agree with the segment addition postulate, well, they can't because it's a math rule, it's a math law. Okay, VW, plug in values here, is 37. WX is what we're trying to find. VX is 144. And again, we've created a rather simple algebra equation for us to solve. Ellen, you waited so patiently. What is the value of WX?
144 minus 37.
Which is?
107.
107 equals WX, or WX equals 107. Okay. Some more complex examples here. Okay, you may find it helpful to draw a picture, which we will do. So point B is between points A and C. AB is 2x plus 7, BC is 7x minus 8, and AC is 80. Find the measure of AB and BC. To start, let's draw a picture similar to what we have up here. Okay, so it says point B is between A and C. Now, I don't know how long this segment is. It's a measure of 80, but what is 80? So let's draw about there. Do we know whether point B is closer to A or closer to C, or if it's right in the middle? We don't. Okay, and that's not really important. This is just kind of a sketch to help us. I'm just going to put it right there. You can put it someplace else. As long as it's between points A and C, so far we've satisfied this first statement. Point B is between points A and C. Now, the measure of AB is 2x plus 7. That's given to us. So we can write write it in there. The measure of BC is 7x minus 8. Again, that's given to us. And AC is 80. Okay. Now, how do I know that that 80 isn't referring? Let's say that you don't have any of this information above. Okay, I'm covering it up with my hand, but you can still see it. But how would I know, based on my diagram only, that that 80 refers to AC and not BC? It has to do with where it's written. Okay. Notice how my 2x plus 7, it's not scrunched over to the left. It's not scrunched over against point B. It's right in the middle. Okay. Same with 7x when I say it. I didn't write it right next to point B or over by point C. It's right in the middle. 80 is right in the middle of points A and C. That's how I know it corresponds to the whole thing. Okay. It's in the middle of the segment that it describes. If you've got a lot of stuff going on, you might also see something like this, where it's got kind of a thing below it. And that would be saying that from point A to point C is a distance of 80. Okay. What equation can we set up for this? And let's just jump right into the values here. What equation can we set up? We know that AB plus BC equals AC. The parts of that segment will equal the whole. So we know that 2x plus 7, which is AB, plus 7x minus 8, which is BC, the two parts, have to equal 80, which is the whole thing. And again, we've got an algebra equation to solve here. What would our first step be to solve this equation? Audrey? Yes. What would we get from that?
You would get 9x.
Good. 2x and 7x is 9x. Good. Yep. Positive 7 and a negative 8 give you a negative 1, which would give us 9x minus 1 equals 80. Excellent. Excellent. And it becomes a fairly simple two-step equation to solve. We start by adding 1 to both sides, dividing both sides by 9 to get x by itself, and we get the value of x equals 9. Which is our answer, right?
Yes.
No! Because what was the question? What were we trying to find? That's the other danger in geometry, is that oftentimes you do need to solve for x, and we're so used to, because of algebra, once we solve for x, then we've answered the question. No. We need to find the measure of A, B, and BC. We did have to solve for x, but now we have to use that value in the context of the question. So, if x is 9, which we've proven it is based on solving the equation there, what is the measure of AB? AB is 2x plus 7. X is 9. So AB is 25. 2 times 9 is 18, plus 7 is 25. BC, 7x minus 8. If x is 9, then what is the value of BC? Alan?
55.
I'm sorry, but no. Julia?
48.
No. 7x minus 8.
We like to use a calculator.
Sure. What do we get?
55.
What was that?
55.
I'm sorry, but no. And when I say I'm sorry, I truly mean it, but I have to do this. You said 50? That's actually not a number. It's pronounced 55. 55. When I said I'm sorry, I meant it. I told the student in the blue group that I did this to that he can not like me for 24 hours, but after that we're cool. So same thing, Alan. Same, you can not like me for 24 hours, but after that we got to be cool. 55 is the answer. Okay, 55. And we can verify that we're right here because if AB plus BC equals AC, does 25 plus 55 equal 80? Yes, it does. So we know that we're right. Okay. The second one I'm going to leave you to do for homework, just like I did with the blue group. Same kind of situation here. Point B is between points A and C. Only this time, the information that you're given is a little bit different. AB is 6x plus 12. BC is 29. AC is 19x plus 15. So in the first one, the variables were contained in the two parts, and you were given the whole. Okay. In this case, the variables are contained in one part of the segment. You're given the other part, and then the variable again in the whole. So your equation is going to look a little bit different as far as where the variable expressions go than the first example we did, but same general setup. Start with the picture, plug in the information you know, and then set up your equation. The bottom one, the brain buster, which is homework. It's not an excuse to not do it because it was hard. But draw segment AF that includes points B, C, D, and E in between and in that order. Okay. Now, before I draw it, actually no, I'll draw segment AF here, and I want to make it fairly lengthy, because I'm going to have a lot of points between here. Okay, there's segment AF. Before I start plotting points B, C, D, and E, I'm going to read through my given information here. It says segment AC is congruent to segment CE. What does that tell me? What does that tell me? That if AC is congruent to CE, yeah. The same length. So as far as where point E goes, I'm just going to put it over here. If point E is there, where should point C go?
Same length away from A.
Right, in between A and E. Okay? If AC is congruent to CE, that means that they're the same length, and so C should be as close to the middle of A and E as you can get. Okay? And as far as points B and D, I don't know if B is closer to A or C. I'll just put it there. I'll put point D closer to E just to, the other two is not quite as important. My next piece of given information is AE. So the measure of AE is 50. What does that tell me? AE is 50. What else can I conclude from knowing that? Audrey?
That all the segments within A and E are going to equal 50.
Okay, so AB plus BC plus CD plus DE are all going to be 50, right? Because the whole thing, AE, equals 50. What else can I conclude? So far I know that AC is equal to CE and that AE is 50. There's another piece of information here that I can get from that. We intentionally put point C halfway between points A and E, right? Audrey?
That A and C and E are going to be the same length, so it's going to be half. It's going to be A and C, and half is going to be C and E.
Okay, so what's the measure of AC?
Oh, it's going to be 25 and 25.
Exactly, right? No, you're fine. Let's walk through what she said here, Okay, we put point C exactly in the middle of points A and E because we know that whatever AC is, CE is the same thing. We were then told that AE, that whole segment, is 50. Therefore, what Audrey's saying is that, well, we know that AC is going to be 25 and CE is going to be 25 because they have to be the same and together they have to equal 50. Now again, how do you know that 25 refers to AC and not BC? Because it's in the middle of points A and C. How do you know that this 25 here is for CE and not CD? Because it's in the middle of points C and E. And together, 25 and 25 make 50. Everyone seeing that relationship there? Okay? That's how geometry is like a puzzle. You know, you're kind of given clues, and you have to see how it all fits together. The next piece of information says CF is 35. CF is 35. So I'm just going to take this and kind of draw it over here just so we can kind of separate it from the whole picture here. I'm only going to focus on segment CF. Okay, so I'm kind of plugging it out. I've got D in between here. Okay. And I've got E over here. CF, the whole thing, whoops, is 35. I know that CE, based on what we've already talked about, CE is 25. What other piece of information can I get from this? And I guess I'm kind of looking for, you know, your objective here is to find, you know, AC, CE, EF, DE, BC, AB, AD, BF, and AF. We've already found AC and CE. They're both 25. Knowing that CF is 35, what other segment length can I solve for here?
You can conclude that EF is 10 because 10 plus 25 equals 35.
Exactly. Okay. Two parts of that segment. I can take D out of here. I'm not even, not using it there. Kind of make it even simpler. CE is 25. The whole thing's 35. That means EF must be 10. So that 25 plus 10 equals 35. Okay? Questions on this? It's a different way to, I don't know how that happened. It's using algebra for a purpose, you can kind of say. Sometimes you might be thinking when you're solving an equation, why do I care what x equals? When am I ever going to use this? Now we're kind of using it for a purpose here, right? But the rest of your assignment is to finish this one up here that we didn't do together, and find the rest of the segment lengths that we have yet to find: D, E, B, C, A, B, A, D, B, F, and A, F. Okay. All right, final things before we sign off. I believe in the 6 of you. That is how you math.
Don't forget to like and subscribe.
Oh, brother.